Hey guys, it's me, and today we are going to be doing a quick calculus video on integration by separation of variables. So without further ado, let's go ahead and get started. I'm going to start off with a brief explanation, and then we're going to go ahead and get into an example problem. But yeah, let's go ahead and get started. Now, this problem right here is a perfect example of separation of variables. The reason why is because there is both an x and a y on this side of the equation. Now, you're probably looking at this and it does not look that easy to integrate, does it? Because there are two variables on this side. You can't integrate something super easily if there are two different variables, which is where separation of variables comes into play, because we have to separate these variables. So we're going to start off with this problem to start as an example problem, and then we'll go ahead and do a more complicated one. But yeah, let's go ahead and start with separation of variables for dy over dx equals xy. Okay, so to start off, we need to make sure we know what our end goal is. And basically what we need to get to is something that's set equal to y. So y equals something. Now, if you're looking at this, some of these variables we need to get out of the way as quickly as possible to make this so much easier on ourselves. And we're going to start off by getting rid of the dy and dx. Now, to do that, we're going to need to make sure that the dx and x are on the same side and the dy and y are on the same side. So step one is making sure those dy's and dx's are with their respective variables. So let's go ahead and multiply both sides by dx to get that dx out of this side. So times dx times dx. And this is typically what you'll do on most separation of variable problems, is starting off by multiplying by dx. And so it ends up being, we can end up getting rid of these because those cancel out. And then it's just dy equals xy dx. Now we still have that y on this side. We're almost there to having the dy and y on the same side. All we need to do is divide this side by y, and you should know these rules for getting functions on different sides of the equation from your earlier maths. But yeah, so we're just going to divide both sides by y. And I like to write this as 1 over y dy equals, and then it will just be x dx. And now we did the first step. The dy and y are on the same side, and the dx and x are on the same side. So now we're ready to go on to the next step, which is going to involve some integration. Now, since we have the same variables on this side and on this side, we can integrate each side separately. So we're going to go ahead and take the integral, it's a little silly integral sign, of this side and this side, and then we'll get to our next step. So let me go ahead and integrate 1 over y. Now, if you know from your integral rules, 1 over y is the integral of that is just equivalent to the natural log of the absolute value of y. And you're going to integrate this the same way you would with an x, except the one difference is you're not going to add that plus c. Now, so we have the natural log of y, and that's equal to that. And then for this one, we're going to go ahead and integrate it. And from your reverse power rule, we should know that this one is just equal to x squared over 2 plus c. See how I included the plus c here, but not there? You're always going to do the plus c for the x's, but not for the y's. So now we have the natural log of y equals x squared over 2 plus c. Now I'm going to go ahead and write it really big, and we'll move on to the next step. Okay, so I just rewrote it a little bit bigger, but now we have y on its own side and all the x's on their own side. The only problem is the y is trapped in this natural log. So you see the natural log right here? Now we can't have that for our final answer, or we won't get credit on the AP exam. So we need to get this natural log out of the way. And if you know from your natural log rules, the only way to get rid of a natural log is doing e to that. Now, e to a natural log of something is just whatever is in the natural log. So this would be equal to y. So we can put a y down here. But you know, if you do something to one side of the equation, you have to do it to the other side too. So we're going to take e to x squared over 2 plus c. And that's okay. I know it'll be a little bit more complicated than this side, which is just going to be y. But we're going to have y equals e to the x squared over 2 plus c like this. Now we can go ahead and bring the c down here from our exponent rules. And now we're almost to our final answer. Let me go ahead and write it up top. Y equals c e to the x squared over 2. And c, like I said, it's just our constant. And so this is our final answer, and y is on its own, so we can check that off. And x is on the other side, and there's no dy or dx in there anymore because we already integrated that in an earlier step. So that's all you need to do for separation of variables. Now, sometimes separation of variables will be used before a problem asks you to find the particular solution or the initial value of a certain problem, but this is the basic format of how you do it. You first have to get those dy and dx's out of the way, and then step 2 is just getting y on its own with no crazy things around it. I hope that helped. I'll be doing more complicated examples in future videos. Thanks for watching, and I'll see you guys again in the next calculus video. Bye!